Hello and welcome again in the course on power electronics, circuit and devices. So in this slide you must be looking at power electronics, which is associated with fields like signal processing, analog and digital devices, electromagnetics, semiconductor, control, power systems, electrical machines, circuit theories. So as you can say, power electronics literally touches all these fields and contribute to all these areas as the subject where it delivers or provide the control or provide the circuit arrangement designing. And in terms of a power electronics engineer, you must be able to have a little bit knowledge of all these areas to design a power electronic circuit for related to these areas. So now let us move ahead and see the next. Here, classification of power electronics and semiconductor devices. In this, we are going to start the subject with different switches. And in this, as you can see, the power electronic semiconductor devices or switches, they can be classified into the following bases. The first one can be the uncontrolled turn on and turn off. For this, the devices like diodes are most suitable. Then if we discuss about control turn on and uncontrolled turn off device, for example, SCRs, then controlled turn on and off characteristics, they are from the example of BJT, MOSFETs and GTOs. Next is under the category of continuous gate signal requirement, and here the examples are BJT and MOSFET. You can see some of the devices which requires pulse gate requirement. So the examples are SCR and GTOs. Then we can see bipolar voltage withstanding capacity devices. They comes under the category of SCRs. Then we have unipolar voltage withstanding capacities like BJT MOSFETs. We have bidirectional current capability devices such as TRIAC and RCT. And then it can be unidirectional current capability such as SCR, GTO, BJT and MOSFETs. Now let us see the description of devices based on terminals. So if we call about two terminal devices, it can be a category where we are discussing input and output. So this can be of course under the category of diodes. If we discuss three terminal devices, then we have multiple category of devices such as MOSFETs, JFETs, IGBT, BJT, thyristors. So they come into these categories, and here you can see minority carrier, majority carrier and minority carrier devices. So once we will dig deep into the each device characteristics, we will discuss how these devices workings are basically categorically dependent on carrier devices. Moving ahead, this is an interesting graph which has been taken from a book called Ned Mohan, T.M. Underland and W.P. Robbins. And here we can see the categorical differentiation of MOSFET, IGBT, GTO and thyristor based on three axes. One here represents voltage, one represents current, another one represents frequency. So here you can see this beautiful classification based on a rating of a device and how these devices are going to be used under what category is represented along with the next graph, which is adjacently displayed here. So in thyristor, you can see this device is coming under the category which have uh, the capability to carry the high voltage and high current, but this does not operate as a high frequency device. So the phenomena here is like wherever the devices are needed for high power rating, thyristors is the obvious answer. Then in the next category, when you see GTO, which is shown here next to thyristor, It also has the capability of high current and high voltage rating, but here it is much better in terms of frequency response. So you can see the frequency handling capability of GTO is much better than thyristor, and it provides, as earlier we have seen, the different control capabilities as well. Next, you can see IGBTs. For majorly industrial application, you can see the device voltage rating and current rating is somewhat reduced, but the frequency handling capability is increased. So this device is most suited in this industrial application where the control of drives, control of voltage source inverters, current source inverters are required. So you can see IGBTs here having the high capability of carrying current and voltage as well as the capability of handling the frequency. Then you can see MOSFETs, which is not having the high capability of handling voltage and small capability of handling current, but the facility of handling the frequency is huge here. So up to from the range of hundreds of kilohertz to megahertz, you can see this is the only device which is suitable, which requires a fast switching operation. So we have seen here in this graph that MOSFET, IGBT, GTO and thyristor, these four devices based on voltage, current and frequency, how they can be classified. And on the right hand side here, you can see some of the applications of devices such as thyristors, which are basically used in the area of power transmission, in and a part category of GTO where you can see it's also used in power transmission, motor drive, traction pumps and iron mill. Whereas you can see when you move ahead on the right hand side, you can see discrete IGBT and module IGBTs. They are more in demand in motor drives for traction pumps and iron mill. It is used in robotic welding, UPS, industrial inverters, etc. But MOSFETs, FETs, discrete MOSFET devices, GaN or silicon carbide devices, they are highly used in PV inverters, adjustable speed drives, pumps and automobile sector. So basically these are the devices which are highly used in switching power supply, and these device provides very high response in terms of frequency. So MOSFETs, and of course with the recent advancement of silicon carbide and GaN devices which offers low losses and fast switching, it's taking over the market of PV inverters and several other areas which requires fast switching operations. So next is to discuss about the design of power electronics equipment. And here in this category, we can see the design of power electronics equipment is majorly divided in four different parts. One is starting with you must be able to design the power circuit, and then protection of those power devices is required to be given. Third is determination of control strategies, how to control the circuit elements. Here it is decided, and then next is to design the logic and the gating circuit requirements for handling the power transfer. On the right hand side here you can see a small graph where you can see the power which is available or flowing from the input side coming through input filter to the power converter is majorly given back to the output and to the load maybe, and then after that here you can see to drive that load the basic switching control is generated, and then that switching control signal is directly fed to the switching operations for the switches which is there used in power converters. So by controlling the on and off period here by looking at the position of the load, based on that the switching is decided, and then based on that switching the controlling of the signal pulses is given to the power converters. So just for the curiosity of learners, let me just present you one of the case of electric vehicle or the advanced vehicles these days which requires so many electronic control, As you can see, more than hundreds of electronic features are embedded with the use of power electronics. And here, by taking the input signal as a speech or input signal as a light, a lot of output has been controlled by using different variety of sensors. So how to control those sensors with the use of internet and with the use of different signaling techniques, we will see one by one. And I hope this slide is making it more interesting and curiosity is increased by looking at the various use of power electronics in the recent areas and fields. So see you in the next session. Stay tuned. Thank you.